still on lockdown, and this week I think my brother's had his milling machine 3 months, and he sent me an update on all the modifications he's done to it since he's had it. So let's go into his workshop and see how he did it.
First rework is I've had to increase the diameter of this knob that engages the clutch, which engages the feed on there. So I've had to make a new control, this knob that used to be this size, and I just couldn't get the grip, so it would be slipping on this control. So I'm thinking I'm putting feed on where I'm not actually putting any feed on. So I'll just remove that so you can see. So it's just mainly a larger diameter. So I've made a new handle, recessed it, utilised the thrust bearing just to allow me to put more load on to engage the clutch. So this is the clutch part of the system, just looks like a phosphor bronze taper that has to engage in this other half. It's pretty standard for these machines, the spring in there. So I'll just reposition that again, so it's on the keyway. So it just takes a much less effort to engage that in a positive way, whereas the original knob, I just couldn't get the power on there to be comfortable that it's engaged properly without any slip. On the front of the machine I've removed the original plate and the digital readout as part of that, because I'm putting a DRO system on here with glass scales, which is what this part is, the glass scale. What I've decided to do is I've got a block of aluminium behind that utilises the original fixings for the DRO for this one. So I've not drilled the machine or altered it in any way. So I made this block that bolts into the aluminium block that sits into the cavity where the DRO used to locate. Then obviously threaded some of that all thread bar and made a new quill plate. The quill plate also houses the rod for the linear scale, for the glass scale, for the position of that. And I'm trying this system out, which I've seen on YouTube. Quite a few people have made one of these, just to see how that gets on as a quick location instead of winding a nut up and down for the depth stop section. So it'll act as a depth stop and lock it in at a certain height as well, stop it returning if I didn't want to lock it on the quill lock handle here. This I've had to make longer to clear the glass scale. You can see some wires here which I'm just experimenting because I've got a light mounted at the front, because I find that they're always at the back and cast a shadow, so you either need two, and you've probably got two shadows casted, but so I've thought I'll just put it at the front. Not used it in anger yet to see whether that's a good location. It might need to come a bit further forward, so just to increase the angle. So that's got to be tested out to see whether that's a good location, and once I'm happy that that is location for it, I'll probably run these cables into a little tube so you can actually see the cables, and they'll work up inside here. It's all low voltage, there's no danger of electrocution from that system. For the quill plate, I've made this out of some 20mm flat aluminium, machined it in a rotary table, then cut a slot down with a clamping bolt to go through, so that fits over the lower boss of the quill. And as mentioned before, that then gives me the capability of mounting the depth stop thread and the rod to support the sensor head for the glass scale. Part of the machine we've got the glass scales mounted for the DRO. As mentioned before, I have to extend the shaft on this locking pin to clear this. This is a 15mm diameter aluminium rod that's been flat machined on one side to accommodate the clearance for the locking pin, because it's all a bit tight around this area, and the glass scale sensor to be mounted on. As you can see, that's moving up and down there. That's just bolted with a recessed cap head bolt up from the bottom. Back on the same side on the machine, I've increased the height of this support bracket for the control box. It used to hit this unit here, which houses a switch for the safety guard. It's one of the safety features that will switch the machine off unless your safety guard's in position. Obviously the safety guard's not in there at the moment, but it used to foul and hit there, so you can only rotate it that far, which may be enough anyway, but it's just nice to move it out of the way when I get it back or something like that, and just to go have a wider rotational. Okay, I've also decided to make my own power traverse using a motor that's very similar to a wiper motor, but it's got a higher ratio. It's a 50:1 ratio. I've made a collar that screws onto the original plate, end plate, so it screws in from the back and everything's mounted on this collar. So I have a sleeve that goes inside this collar and an eccentric on this shaft here that goes into a slot that allows me to engage and disengage the drive. So obviously that's disengaged, it pulls the unit back. On this drive shaft I have to make a new drive shaft for this motor with a square on the end. It's I think it's 3/8 square for the small sockets. So I've got a 5/8 socket on there that engages on a nut that's splined to the main shaft. And with this design, no swarfs are really going to get into the mechanism. Should be fairly user friendly. Obviously in conjunction with this you have to have limit switches. I've constructed a box which I've got 2 micro switches that are built into this box that mount through the same 2 holes that holds the pointer. So again, no drilling or rework to the machine itself. I have noticed that the way I've designed it, the switches are in a position where dirt or swarf can get down the back and could actually stop the switch working, so I will revisit this. I have made a little plastic sheet that goes over there to try and limit the amount of swarf that will go down there, but realise that it is in a vulnerable position, so this will need redesigning. And then the wires from there feed up the back parallel to the other scale, linear scale, to the control box. Okay, moving underneath the swarf tray, I've mounted a power supply for the feed, the electric feed. In here is the stepper control motor electronics that varies the outputs. It's a pulse width modulated system, varies the outputs to the motor. Obviously I've got mains power in, power out to the motor, and cables that connect to the control box with just magnets on the back that I can mount this higher up in a convenient place or hold it, and I can vary the speed and its direction, left or right. On the control box I've got a power output which will power the DRO readout when that arrives. Also to mention that I've made a sprung loaded adjustable stop that obviously engages with the micro switch to stop the traverse automatically. Yeah. This is the advantage of the magnetic backing on this control panel. I can mount it anywhere that's convenient. Run the wires around the back so they don't get in the way of the cutting operation, and I can just work it from here and control the speed, feed speed and direction. So I'll just slacken that off. I'll run it up to there, close to the switch, so I can just show you how that works. Just a quick demonstration of it in operation. So we have a slow, I find I can go, this is a percentage by the way, with the pulse width modulation, the percentage, not actual speed of the motor. So it'll run down to about 15, 16, and you can see that it's just turning very slowly, and it will go up to 100%, and as this motor is 50 RPM, that's its maximum. Now I don't know whether you could see in the shot that the limit switch has been triggered automatically, and I've wired it in such a way that obviously I can go back the other way. So from 50 RPM all the way down to about 16%. I've not worked out what that is RPM wise. The Z-axis is the quill movement, so I've mounted the glass scale on the turret part, so it's a direct replacement for this readout that I've removed. So once my DRO arrives, I've actually replaced that with a better system for the glass scale mounted on here. Y-axis, I've used some angle aluminium mounted to the machine using 2 fixing bolts at each end. Then I've got some more angle aluminium that comes down at 90 degrees to this to mount the glass scales too. So the glass scales are bolted this way into these other plates, then obviously the cover on the top of that. So the X-axis is mounted on the back of the table. Again, some angle aluminium screwed with 2 cap head bolts to the table, and then the glass scales mounted to that. I've used cap head bolts that hold this the glass scales to the table. I've decided to put a groove in there and use a circlip on all of them just to hold the cover on. It's always an awkward way of trying to figure out how I can hold the cover on, stop it drifting about. So that's the method I've used on the milling machine on all the scales.
Well, that's all the updates to the machine so far. Hope that was useful, hope you enjoyed it, and we'll see you next time on Enots Engineering.